Hey, today, we're going to talk a little bit about objects. Is this a shape? What shape is this? You might say like it's a cylinder, or you might say it's maybe a rectangle from the side view, kind of. But really, in actuality, shapes are two-dimensional, aren't they? Isn't a square just a flat thing? Or a circle, isn't that flat? Have you learned yet the difference between two-dimensional and three-dimensional? Like, if you're watching your TV, it looks three-dimensional, like the people run around and run away from the monsters, right? It looks three-dimensional, right? Well, yeah, they're filming a three-dimensional world, right? But if you walk up next to the TV screen, like right to the side of the TV screen, and you look at the TV screen, I mean, it's all flat. They're tricking you into thinking it's kind of three-dimensional, right? And it kind of draws us in. But really, everything you're seeing there is just flat shapes, right? It's all two-dimensional. So, to start off with 10.3 today, you need to understand that shapes are two-dimensional. Here's a rectangle, right? It's two-dimensional. It's flat. Now this actually, if you want to get really technical, it's three-dimensional because this actually does have width. Super tiny of a width, but you know, in general, this is just a shape. It's flat. But this water bottle here, it's a three-dimensional object. It not only has an area, a shape, it has depth. Ooh, ooh, right? So three-dimensional has like a width, a length, and then a depth. That's why it's three dimensions. Length, width, depth. Now, we would not call this then a shape. We would call this a solid. And that's what we're talking about today. Solids. My little paper box thing that a student made for me a while ago that I keep a bunch of Sharpies in. This is not a square. Okay? This box is made up of a square, and in fact there's triangles here, but a square for this side, square for this side, square for this side, square for the bottom, right? Hollow on the top, but a bunch of squares make up this solid. This is a solid, right? These scissors are a solid. Okay? Now, there's another word here called a polyhedron. A polyhedron is a solid that's made up of polygons. What's a polygon again? A polygon's a shape. Now, polygons are shapes with only rigid sides, like straight sides, and it has to be a closed figure. Think of a square. Think of a parallelogram. Think of a kite. Think of a diamond. Think of a circle. Oh, wait, no, not a circle because a circle is curved. Polygons don't have, so an octagon is okay, but not a circle. So a polyhedron is a solid made up of polygons. Is this scissors? Is it a solid? Yes, it's an object. It's a three-dimensional object. Is it a polyhedron? No. It's not made up of polygons. Pretend my box here is actually a cube, closed in. Closed-in cube. Is this a polyhedron? Yeah. It's a special kind of polyhedron called a cube because it's made up of polygon of a square, polygon of a square, polygon of a square. It's made up of polygons. Cool. Let's take a look at your book. They're going to show you some other different three-dimensional figures. And they tell you here at the top, a solid's three-dimensional figure that encloses a part of space. Are you a solid? Are you a three-dimensional figure that encloses a part of space? Yeah, you're a solid. Some of you are a little more solid than others. A polyhedron. Are you a polyhedron? Solid that enclosed by polygons. You would look very weird if you were a polyhedron. If you were all polygonal. Alright, polyhedron has only flat surfaces. The polygons that form a polyhedron are called faces. So this cube How many faces does this cube have? Well, it's got 4 sides, it's got a top and a bottom. That's 6 faces. Now let's talk about how we classify solids. What are they called? This is a prism because it's a polyhedron, so it's got the polygons. Remember, polyhedron, polygon. Okay? Prisms have 2 congruent bases that lie in parallel planes. The other faces are rectangles. So here's a triangle base, another triangle base, and they are perfectly parallel to each other. And then their sides that connect these 2 bases are rectangles. Can you imagine right now a pentagon base, another pentagon base that's parallel, and say it's congruent, it's exactly the same, and then connect it by rectangles to make like a tubular thing? Yeah. Would that be a prism? Yes. What type of prism? A pentagonal prism. This is a triangular prism. Okay? Pyramid has a square base. Pyramids have one base, the other face, oh sorry, it's not square base, it just has one base, and then the other faces are triangles. So a pyramid has to be made of triangular faces. This happened to have a quadrilateral base, meaning 4, but could you have a pentagon? I'm going back to my shape here. Pentagon, what if I want to stick a pentagonal pyramid at the top of this? Is there such thing as a pentagonal pyramid? Are these all triangles? All the faces of this top shaped triangles? Yes. And the base is a pentagon, so that is a pyramid. Yeah, nifty. Cylinder has a circle for the bases, right? And then this that wraps around those is a kind of a curved rectangle. Got a little scrape on my hand there. Curved rectangle. If you flatten that out, right? It's a rectangle, just curved around these circular bases. Okay, a cone, solid with one circular base. You know what a cone is. And a sphere is golf ball, baseball, soccer ball, right? Sphere is a solid formed by all points in space that are the same distance from a fixed point called the center. So there's a center, and every one of these points on this outside, in all directions around the center, they're all the same distance away from the center. Say they're all 2 centimeters, 2 centimeters, 2 centimeters, 2 centimeters, all the way around every direction from that center. All right, cool. Not done yet, though. You might think this is really easy, but it's going to get a little tricky. Classifying solids here at the bottom of your page. Classify the solid basically means name it. Tell whether it's a polyhedron. Is this a polyhedron? Remember, polyhedron is a solid formed by all polygons. Is a circle a polygon? No, because it's got a curved line. So this is a cylinder, right? It is not a polyhedron because it has circles for their bases. Now, there are 2 more points, 2 more terms that you need to know. The segments where faces meet are called edges. Okay, segments where faces meet. This face, this rectangular face of my pentagonal prism, see that face right here? Meets this face at this bold dark line. That face meets that face at that line. That is what is called an edge. A vertex is where lines meet. Let's see what their fancy smancy definition is. A vertex of a polyhedron is a point where 3 or more edges meet. 3 or more edges. That's an edge. Is this down here an edge? Yeah, because the bottom met the face of this. The bottom is a face. They're all faces, right? And this is an edge. So look, 3 edges met at, what's that called? A vertex. Vertex. Plural for vertex is vertices. How many vertices do you think my awesome little spire shape here has? 1, 2, 3, 4, 5 at the bottom. 1, 2, 3, 4, 5 here the midway up, and then 1 at the top. So 11 vertices. How many faces are there? Well, 1, 2, 3, 4, 5 around the faces here. The bottom is another, that's 6. And then 1, 2, 3, 4, 5 triangles around this. That's 11 faces. I did not include this top pentagon because it's enclosed inside the shape. So, they're actually going to have you count for some of these solids, some of these polyhedrons and other solids. They're going to have you count the number of faces, edges, and vertices. Now, this might seem easy to you, but you better pay attention and go slow, or you're going to mess up. This is a pyramid. It looks like a pentagonal pyramid. Has 6 faces because it includes the bottom. Don't forget that bottom, guys. Okay? Don't forget, yeah. It's not just the sides, it's the tops and the bottoms. So 5 around the sides, 1 on the bottom, 6 faces. 10 edges, got to visualize those ones behind, and 6 vertices. Okay, now, how can you sketch these yourself? Notice when I sketched mine, I used a dotted line for a line back, an edge back here that we couldn't really see. Now I didn't use a dotted line for this and this because when I first drew it I didn't have this pyramid on top, but this line should be dotted and this line should be dotted. So that's one trick to drawing these three-dimensional figures. Now this is saying show 2 ways to represent a triangular prism. Well, one way is just to draw it. Okay? You guys, that's what you're going to default to. Oh, well, just sketch the solid. Let's just draw a cube. Let's just draw a triangular prism. Use dotted lines for those hidden lines. Okay? But the other way to represent a solid is to sketch it multiple times from different views. So here's a triangular prism. Here's the top view. Here's the view from the front. Maybe you're standing in front of this thing, and this is what you would see. And here's the view from exactly the side. Okay? How would I draw that for, forget this pyramid part, let's just look at my pentagonal prism. How would I represent that without drawing it like this? Well, top view would just look like this, right? Side view would look like a face here, and then it would kind of, that face would come out a little bit, and that face would come out a little bit. That'd be a side view. So that's side, this is top. And then maybe a front view. You could also, like if I was standing right here, looking this way, I was standing here, looking this way at the pentagonal prism, I might see what would look like this, wouldn't I? Whereas if I'm standing right here at the side, or the front, whatever you want to call that, I would see that. So, anyway, 2 different ways to draw these guys out. And it looks like today you're going to be kind of visualizing, counting edges, vertices. You're going to have to even imagine the hidden lines there. And you're going to be classifying these solids. What would this classify as? Is it a polyhedron? Well, let you figure that out. So, that is not shapes. Those are solids.